show you what you have here in Crete. So, our main exhibit is the wireless optical system Kuruza, which is for wireless communication between buildings in urban environments at 1 or 10 gigabits per second at about 150 meter distance. Now the system uses light for conveying the information, and here we're presenting this in an interactive setup with the whole history of devices behind it. So you can see displayed generations from 2 to 2.0 at the end, which are currently deployed, and we are testing them for wider scale use. This whole story is a nice exhibit of how 3D printing affected our development process and how the iterations went throughout the device designs and how we optimized the whole setup to come to a very stable system right now. Further on, we have the good enough CNC setup, which is our take on affordable and effective manufacturing globally. Since we want to create and have actually created machines that empower people to do CNC machining and computer-controlled design pretty much anywhere, because the designs are made from stock steel tubing and other very common parts, such that they can be made absolutely anywhere in the world. Here we're displaying the use of these machines for different purposes, anything from using microscope to see some cells, to CNC milling to create chairs and other projects, for example A-Care Twist Tab, a few others from wood, and create useful products here on the spot. Further on from here, it's the good enough CNC 3D printer workshop. Our ArsElectronica 3D printer is currently being replicated by a local team, so you can see the 3D printer design being assembled, and it will be finished in a few hours, so feel free to have a look at it as well.
Hi, welcome to SimbiLab. This is a part of IRNAS since February 2016. Here we try to develop and evaluate DIY and simple to make lab equipment. We are part of a very strong and ever-growing DIY bio community, and a lot of the designs that we are using were also developed by other people, like this DIY microscope from bacteria, or the foldable spectrometers from Public Lab, but we are also developing our own designs, like this spectrometer, which has its own light source for transmission and fluorescence. What we try to do is not only to develop the equipment, but also use it in real research projects like mushroom cultivation and in vitro ecology. And here let me take you to our newest project, which is the DIY and open source bioprinter. Currently we're trying to evaluate and establish parameters for different materials we want to print, also in collaboration with our partners from the local university in Linz, who provided us with some testing materials, and the medical faculty in Maribor, with which we are trying to establish a collaboration. So here we have a small space for actual work at the festival to prepare solutions, other stuff. And in the end, I want to show you a small project that we did together with Safecast, which is the development of a Geiger counter with an integrated GPS device for online tracking of background radiation.